bum, 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 bum. Okay, let's hope that looks better. Okay. I think we're in a better spot. Does it look better? Doo doo. Yeah, it looks way better on my end. Are we good, chat? Are we back? Hello. Are we back? Can you guys see? I see. Okay. Looking better? Are we looking better? Okay. Oxides. Looking good? Still looking good? What even happened? I have no idea. That wasn't even a me problem. That was like I just restarted everything. It wasn't even an internet issue. It was like this weird like server issue with Twitch, I guess. But everyone can see. Yes. Okay. Okay. Twitch being Twitch. Okay. Okay. So, before I was rudely interrupted. Okay. Now, people are allowed to join. It is a no talking thing. We listen. And then at the end, we take a test. Because I wrote a test this time. I wrote a test. We're so cool. We're so cool, okay? So, I might also point at people in the classroom to answer questions, okay? There is a pop quiz at the end. There is. I wrote answers and everything. You're getting graded. Oh, chat, while we're waiting for people to filter back in. So I had this idea of a way to get people to engage. I want to run it by you. So my idea to keep people engaged in what we're teaching is that I would like to do at the end of each stream, we go through and look at like who answered what questions for pop quiz, who answered them first. If you answer them first, you get a gold star. The person at the end of the month with the most gold stars gets a gemstone from my personal collection. I think that would be a sick idea. Maybe a little up for you guys. What do we think of that? Is that a cool idea? Dude, I'm watching this thing like a hawk. Gonna solo that? Hey, no, 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 no. Anxiety of a test versus winning a gold star. Find a seat. Be quiet. Okay, we're just kind of waiting for people to filter back in. I'm gonna talk to, okay, 1 second. Okay, we're gonna get another pin for our class peoples. Okay. Everybody say hi to our lovely class. There probably will be more people, but we will see. Here's how this is gonna work, class. Pay attention as much as you want. I'm gonna try and point at some people to give answers when we can. Try and involve you guys as much as possible as well. You good with that? Okay. We're upgrading. We're upgrading. The stream is upgrading. Okay, we also have some visual examples. So we're gonna get that one of those out right now. Okay. Upgrades, people, upgrades. Okay. Here's big question as we switch from Crazy Dave's theme to Watery Grave. We love Watery Grave. Okay. Here's the big thing. What is an oxide? Does anybody have any idea what an oxide is? Okay. An oxide is a compound where one or more metals bond directly to oxygen. Okay? So, recap on this. A oxide is what? Something bonded with oxygen. Good job. So, an oxide is a compound where one or more metals bonds directly, this is important, directly to oxygen. Okay? Thank you for the follow, AJ. Appreciate you. Okay? Bum, 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 bum. Okay. In the gem industry, we have a couple examples of this. Okay? One of them we've talked about quite a bit. So we're going to write it down. One of them is sapphire. So if we're talking about sapphire as an oxide, what else would be with sapphire, guys? It would be rubies. Rubies. Corundum. Corundum is an oxide. Okay? What's another one? What's another one we think is an oxide? What's another one we think is an oxide? We have like 4 main ones. One of them is spinel. Another one is chrysoberyl. And then another one is hematite. Okay? Now, recapping this. An oxide is a compound where one or more metals bonds directly to oxygen. We have a couple examples. We have our corundums, which is our sapphire and our rubies. We have our spinel. Thank you for the follow, Foggy. I appreciate you. And then we have our chrysoberyl. Then we have our hematite. Okay? These are the ones we're going to cover today. There are most likely more, but these are going to be the most simple that we're going to cover today. Sound good? Sick. Love that. Okay. We can define this by... Okay. We can define this by metal plus oxygen equals oxide. Okay? Now, what do you think our sapphire and ruby chemically looks like? We're talking about basic chemistry. We're not talking about all the colors, right? But sapphires and ruby look like this. Al2O3. What does that mean, chat? So this is aluminum. This is oxygen. Okay? For spinel, it is Mg. Okay? Mg. Al2O4. For chrysoberyl, it is Be. Al O4. Okay? And then this one is Fe. 2O2. Or O3, actually. Sorry, my mistake, class. Okay? This is sapphire. This is sapphire. Oh, brain farting. I keep brain farting. This is sapphire. This is spinel. This is chrysoberyl. And this is our hematite. Okay? How's everything looking so far? Is the stream still up? Like, not lagging? We're still pretty good? Sick. Okay, awesome. Bum, bum, bum. Okay. Does everybody have this good? We're pretty good on this? Iron oxide. Yes. Iron oxide. We love iron oxide. That's good hematite. Good hematite. We love that. Okay? We're also going to try and move a little slower this time, chat. But let me know if I'm going too fast. By the way, one of the things I was trying to ask while everybody was doing, the lagging of Twitch was, one of the things I want to do, there is a pop quiz at the end, I have a good noodle system where the more stars you get, at the end of the month, you can get a stone from my personal collection if you have the most stars. I think that would be fun, don't you? I apologize if I'm repeating that, but I don't know what I said or what made it through. Okay. How are we feeling, class? Are we feeling good? Huzzah. Huzzah. This is good news. Okay. So, first thing we'll cover first are physical properties, I believe. Or we might just go into each individual one. What do you guys think? So, one thing that is in common with a lot of oxide is they have a Mo of 8 to 9. Does everybody remember what the Mo scale is? Right? Everybody remembers what the Mo scale is? Awesome. So Mo scale is scale of hardness. So this is pretty damn hard when it comes to stones. Now, again, there's a vast difference between 8 and 9. The 9 is 2 times greater than an 8. Okay. So we're gonna go into I think we're gonna go into corundum first. Thank you for the follow, Sky. I appreciate you. Bum, bum, bum. Ba-da-ba-dum, ba-da-ba-dum. Okay. I'm going to turn my air conditioner on because it is hot in here. It's getting hot in here. I'm not taking off my clothes. Okay. Bum, 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 bum. Okay. So, corundum. This is what? What is a corundum, chat? A mineral. That's good. But what are, when we talk about corundum, what gemstones are we referring to? Rubies and sapphires. That is true. Rubies and sapphires. I would like to say, I'm getting pretty damn good at writing on this fucking board. I would like to put it out there. Ah, beautiful. Beautiful. Oh! Find a seat. Silence. Silence. My first gemology class? Oh, I'm so excited for you then. Okay, so corundum has a hardness of 9. Aw, thank you. Hardness of 9. Chemical structure, Al. What does the Al stand for, chat? What does the Al stand for? Stands for aluminum. Aluminum. We love our, or as the Brits would say, aluminium. Aluminum. I hope I spelt that right. Otherwise, we're just going to pretend. Okay. Thank you for the follow, Tired Green Fox. I appreciate you. Okay. So, here's a big thing to note that I don't think we have covered. Corundum is a mineral species. Okay? This is a species. Rubies and sapphires are different. We know why rubies are different. We did a little part of our class yesterday on it. Rubies are red. Okay? This is caused by chromium. Sapphires are every other color but red. And this is caused by a variety of things. For example, yellow sapphires are caused by iron. Blue sapphires are caused by titanium and I believe another mineral. So, rubies, red. Sapphires, everything else. Okay? Now, one thing we will cover in this, because we're going to do more, we're going to talk more about gemology here. We're going to say that this has a adamantine to vitreous luster. What is luster, chat? We talked about this yesterday. What is luster? The Real Hope, thank you for a follow. I appreciate you. What was that? Hey, we reached a follower goal. 410. Hooray. This is good news. Good news, everyone. How light reflects off a stone. Great. So it has an adamantine to vitreous luster. Okay. Now, another thing we will talk about is it is part of the trigonal crystal system. Okay. Now I have a visual aid for this, so we will use our visual aid. Okay. Where is my teaching stick? God, I love having a teaching stick. Okay. Here are our crystal systems. We have our cubic, tetragonal, monoclinic, orthorhombic, triclinic, hexagonal, and trigonal. This is our trigonal crystal system. This is what makes up the lattice in our corundum, or rubies and sapphires. Okay? We'll put this here in case we need it. And then one thing else, we'll get our handy dandy visual aids out. Also, here, pass this around in class. Okay. I really wanted to make sure I had visual aids for this class. So, this is what the chemical structure of our oxides is going to look like. We're going to use the aluminum oxide as a good example, right? As you can see, our aluminum is directly bonded with our oxygen. You can see this in our sodium oxide, our sulfur trioxide, and our nitrous oxide as well. Okay, so an oxide is where a compound is directly, or a compound of metal, one or more metals, that is directly bonded with oxygen. Okay, oxygen being the key word. Okay, pass this around in class. I love the idea of just throwing something at somebody and being like, pass it out. Okay. Doing quite well, I think. We're going to move into our spinel now. Okay. Does anybody have any questions about corundum? Any questions? Then we will show a visual example of what our rubies and sapphires will look like. This will mostly be sapphires, but just imagine red ones, and that's what a ruby looks like. Okay. This is what our corundum looks like. It does have a quite variety of colors. I'm personally a big purple fan. I do love my purple sapphires. That's for you guys. Then I can delete this one. Bum, 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 bum. Okay. We're actually doing quite well. Hey, Post got it. By the way, I'm not afraid to start pulling stuff from other classes that we do. So you guys better take notes. Okay. Okay. So we're moving on to spinel. Okay. Spinel. Chemical structure. Mg. Al. I believe that's 2O4. Okay. It is part of the cubic crystal system. If you guys would like me to pull out the crystal system visual example again, let me know. I can do that. It is on the Mo. It is a 7.5 to an 8. What is this similar to, chat? What other stone did we learn the other day is similar in hardness? It's topaz. Topaz. Similar to topaz. And quartz. And quartz. Now, the different colors of spinel, which we will use our handy dandy visual aids. Now, boom, kaboom. Okay, so these are different colors of spinel. Now, color can vary from chromium, iron to cobalt. Those are the most common of what we call chromophores. And traces of chromium give spinel a red color. Blue spinel is colored by iron or cobalt, and pink by low chromium levels. Okay? I love the gray. The gray is also very nice, I will say. We're going to get some involvement from our class here. Okay. I'm going to pass this around to each of you. You guys can give me what's your favorite ones of our spinels. What is your favorite spinel? What color do you like? Do we think this guy likes green, chat? The raspberry is very nice.
It looks like a Jolly Rancher. Looks delicious.
It is very nice. Thank you for the follow, Zoshar. Thank you. Is it blue?
It's the lavender.
The lavender one is very nice. Okay. Okay, chat. It's your turn. While I'm writing the next stuff down, what's your favorite spinel color? Which one do you like? It might get a little blurry as I don't look at it. But what's your favorite spinel color? Okay. Okay. Pink and green's glowing. Gray and green. So violet. So many green lovers. Ugh. Looking at the delinquent in here. Black. We love black. Black's good. Okay. So, spinel actually has some historical importance. Okay. Spinel, prior to the last century, that's 100 years. Okay. so prior to the last century, was indistinguishable. Okay? So it was hard to tell. We'll use some simple words. Hard to tell, but it was almost impossible to distinguish between ruby and sapphire. There is actually some history here where there is the Black Prince's ruby and the Timur ruby in the British crown jewels are actually spinels. They are not rubies. But once they are cut, it is without modern technology. Wait, which time frame? We're talking about like prior to a century. But prior to a century, they were hard to tell, almost impossible to tell between rubies and sapphires once they were cut. Okay? It was distinguished its own mineral species in and it was okay. So it was distinguished its own mineral species from corundum in 1783. That's a long time, chat. That is a long time. Okay, so to recap our spinel. Spinel is a aluminum oxide, or I believe this is manganese. Let me double check. I believe it's manganese. Yes. Manganese aluminum oxide. It's part of the cubic crystal system. It has a Mo of 7.5 to 8, which is similar to topaz and quartz. It was distinguished its own mineral in 1783, and it is hard to tell between ruby and sapphire once it was cut until the use of modern equipment. Yes, manganese is Mn. I forget. I hate that they named them the same, similar. I always mess it up because of like, I don't know, I'm dyslexic or something. Tease, thank you for the follow. I really appreciate it. Okay. And the Black Princes, Prince Ruby, and Timur Ruby, magnesium. So it's a magnesium aluminum oxide. Thank you, chat. I appreciate it. Timur Ruby are spinel. I want to get I want to commission my own classroom with this chalk physics, and have like the periodic table and everything. I think that would be fun. Don't you, chat? Okay. Whew. So there's only a couple gems that are harder than spinel, and that is, what do you guys think is in here? What do you guys think is at top of the list? What is harder than spinel? If spinel is a 7.5 to an 8, what's harder than spinel? We know one, diamonds. Another one is alexandrite. Then we have, of course, corundum. Good job, Post. Good job. And yeah, that's about it. Spinels also lack a thing called cleavage. Spinel, we are not talking about that cleavage. I'm looking at you, delinquents. Spinel lacks cleavage. Okay. So they have a superior. What do you think they have a superior resistance to? What do you think Spinel has a superior resistance to than most gems? Oh, we got somebody in the back. What do you think? What do you think they have a higher?
Matching?
Close. We're looking for blows. They're resistant to blows.
Like impact blows?
Yes, like impact.
Okay.
So, heat, close. Their lack of cleavage means that they have a higher resistance to blows or impact. I wrote blows down because I thought it would be easier, but I should have just wrote impact. Okay? Now, here's another thing. We're going to go over a term that we used yesterday. Spinels actually have a relatively high RI. What is RI, chat? What is RI? What is RI, chat? Refractive index. Good job. And what is our refractive index, chat? What is our refractive index, chat? Bum, bum, bum. It measures how light bends when it enters a stone. Good job. Good job. Yes. Okay. Close. Tired. Close. The refractive index, specifically in stones, is how light bends when it enters the stone. Okay? Because Spinel has this super high RI, it means that well-cut stones will be exceptionally brilliant, which is a good thing. Now, I have some beginner notes and advanced notes, so pay attention, okay? So, because of Spinel's lack of cleavage, we know that it is resistant to blows and impact. But this means that it does not split like topaz, or what is another gem that you guys think splits? Does not split like topaz, or what? Or diamonds. So spinels are exceptionally strong stones. They do not split like diamonds or topaz do. Okay? Okay? Are we good to erase this? Is everybody okay with this? Okay. Or I'm going to start erasing. Are there any questions, chat? Are there any questions? Any questions for me? Do we need any visual examples? Any visual examples? I prepped for this. Oh, Sam. Hi. Hi, Sam. Hi, I'm Smokey. I am your teacher for today. We are learning Oxides 101. We are learning what gemstones are oxides. I do these classes to teach and, you know, get people to know more about gems. Okay. We just learned about spinel, and we're going to move on to chrysoberyl, I believe, next. We might see. Depends on how I wrote my notes and how much I hate myself. It's the rock one. That is me. Okay, so my one mod, can I get a shout out for Sam? Thank you. Okay, so we have one more industrial note for our spinels, which is that spinels for centuries were sold as rubies. Red spinels were known as rubies for a time. Okay, but today they've gained recognition on their own, especially for a type of spinel called Jedi spinel. And this comes from Myanmar. And what color do you guys think Jedi spinel is? What color do you guys think Jedi spinel is? Sorry, I had to raid and dash. Had a short stream. Felt sick all weekend. Have a great stream. Love you. Bye. I will take care of your people. We are learning rocks now. Either a blue or a green. You'd be surprisingly off. What do you think? Does anybody in in-person class have any idea what a Jedi spinel could be colored-wise?
Green?
Green? No.
Lavender, purple? Purple, lavender, around that area?
No. What about you? What do you think a Jedi spinel color is?
Is it red?
Closest so far. Orange, red, no. Maybe clear, nope. It is known for being neon pink. Why is it named Jedi? Who fucking knows? But it is known for being neon pink. And it commands very high prices for being neon pink. Okay? So, to recap, we're going to recap really quick. I know that there's no notes on the board, but I know you guys are smart. So, spinel. Spinel is a magnesium aluminum oxide. It is a 7 6.5 to an 8 on the Mohs scale. It's part of the cubic or isometric crystal system. It has no cleavage. What does that mean, chat? What does no cleavage mean? Anybody in here? Anybody in here have an idea of what no cleavage means? Why are you smirking at me like that? Detention. Detention. Okay. It does... no reflective points. No, it doesn't break from impacts. Oh, Sam almost had it. Okay. So, we know a couple of reasons why there's different colors of spinel. We don't need to rehash that. The Black Princess Ruby and the Tamur Ruby are not rubies and are, in fact, spinels. Okay? When was spinel distinguished as its own gem, chat? When was it distinguished as its own mineral species? Oh, we're switching to live class view. Yes, Sam.
1783.
Correct. Oh my god, my chat's actually learning. We're learning. We're learning. Look at all this, and we're listening to good Plants vs Zombies music, which is amazing. Plants vs Zombies music is really the autism of music, I think. Okay, we're moving on. Is there any questions for me? Any questions at all? Any questions from the chat? We're going to rewrite our Oxides 101 while we prepare for our next segment. Bum, 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 bum. Oxides 101. Doing these classes have been actually so fun. Okay. So, first thing we're going to cover now, we're going to cover chrysoberyl. Okay? Chrysoberyl is a beryllium, aluminum, oxide. Okay? Quick, what's an oxide, chat? What's an oxide? This is the whole point of the class. The whole point. While you're doing that, I will write this down. Something bonded with oxygen. It's not something, it's metals. Metals, one or more metals, bonded directly with oxygen. Good job, Eternal. Good job. Okay. It has a Mo of an 8.5. It's part of the orthorhombic. We're going to bring a visual aid for this, for sure. It has an RI of 1.74 to 1.75. And it has an imperfect cleavage. Okay. Okay. So, chat. Our chrysoberyls are a beryllium aluminum oxide. They are a 8.5 on the Mohs scale. They are part of the orthorhombic crystal system and have a refractive index of 1.74 to 1.75 with a imperfect cleavage. Okay? Now, what do you guys think the Mohs scale is? Anybody in chat remember what I said the Mohs scale is? What does it test? It tests hardness of a stone, right? So, right now, we're looking at a pretty high up there stone, but not too high. 10-point hardness scale. Good job. Okay, we're going to bust out some visual aids now. Okay. Here is our crystal systems. So this one is what our crystal barrel is. The orthorhombic crystal system. Okay. Pass this around again. Okay. We're doing good so far. Okay. Now, we'll start going through. Okay. Now, crystal barrel is at number 3 for the third hardest. Encountered natural mineral. We're going to use min for mineral here, just so everybody's aware. So, our crystal barrel actually lies between topaz and corundum, okay? So it lies between these, okay? Bum, 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 bum. There are 3 varieties of crystal barrel. There are 3 varieties. There is regular. There's regular, which just means that it is a transparent variety of crystal barrel that people like to facet. The people like it for its bright yellows. Okay? And I have a visual example of this. So this is what our crystal barrel looks like. This is what our normal crystal barrel looks like. Okay? Okay. Pass that in class. Number 2 is something we call chymophane. What do you guys think chymophane is? Could also be pronounced cymophane, but I don't know. We're going to pretend like I know what I'm talking about. What do you guys think cymophane stands for? We call these have something we call chatoyancy. What is chatoyancy, chat? Something with a wave. Close. What is chatoyancy, chat? This is a term from yesterday. Cat's eye. Good job. So, our cymophane crystal barrels are known as cat's eye crystal barrels. Okay? We do have a visual example for this one. Okay, this is what our cymophane looks like. Now, as you roll this stone, This cat's eye follows. That's why they call it an eye. This line follows. You're so much cooler than my mineralogy professor, Smokey. Hooray! Looks like an eye. That's why it is called a cat's eye. Bum, bum, bum. Okay, we have one more. This one will be surprising. Number 3 is alexandrite. Now, alexandrite is important because it is a color change stone. It turns from a emerald green in daylight, so it's green, to red in incandescent light. So green in daylight, red in incandescent light. Okay? And I have a visual example for this because I was fucking ready for this. I was fucking ready. Okay. So this is what our alexandrite looks like. Okay. So this is compared to our crystal beryl. So no chromium, no color change. Alexandrite is a variety of crystal beryl with chromium resulting in color change. Okay? You might actually like this one, Rice. I think you'll like that one. Okay. So, chromium. What's another gemstone we talked about that has chromium that turns it red? It's part of our corundum family. What is it? Ruby. Good job. Random Snowy. Good job. Okay. Okay. So, we're going to talk about why alexandrites change color, and it might be a little complicated, but it'll be okay. Don't worry, I'm holding your hand. Thank you for the follow, Caden. I appreciate you. Okay. So, alexandrites turn different colors because it is attributed to chromium impurities and their absorption band in the yellow region of the visible light spectrum. Okay? I'm not expecting you guys to know this, but it is okay. Now, there is a term that they like to use for, we'll actually use this side. There's a term that they like to use for alexandrites. They call it Lord Salt, thank you for the raid. 25 people. Oh, that's scary. Hi, we are learning about alexandrites right now. Or crystal beryl, but in turn alexandrites. I will recover this in just a second. Here to get our rocks off. I hate you. I hate you. Okay. Alexandrites are known by one moniker. Emeralds by day. Rubies by night. Why is this, chat? Why are they known as emeralds by day, rubies by night? Okay. Why do you think when we talk about emeralds, we refer to them as emeralds by day, rubies by night? The lights they used were incandescent. Because they change color. Yes, because they change color, and they are known for turning green in daylight and red in incandescent light. This is caused by chromium. Okay? Now, because we have our new people, we're going to cover this very quickly. But crystal beryl is an oxide, What is an oxide? It is a compound where one or more metals are directly bonded with oxygen. In our case with crystal beryl. Crystal beryl is a beryllium aluminum oxide. It is a 8.5 on the Mohs scale, which is a reference of hardness. It is part of the orthorhombic crystal system, which is how its molecules are arranged. It is a 1.74. I will get my water in just a second. It is a 1.74 to a 1.75 on the refractive index, which just means that is how light bends when it enters the stone. Okay? It has an imperfect cleavage, and there are 3 types. There is regular. Can I have my chat pass me up my images, please? Oh, I got these. Hello. So we have our regular, which is our yellows. Then we have our cymophane, which are cat's eyes. They have something called chatoyancy. And then we have our alexandrite, which color changes from green to red. Okay? Good job, chat. Look at us. We're learning. Okay. Okay, we're going to cover the next one. Is everybody okay with this? I'm late, but at least I made it here. Hurrah! Remember, the VOD will be uploaded right after the stream, so we'll be fine. Also, for our new people, we do a pop quiz at the end. If you guys get good stars and stick around, at the end of the month, whoever has the most stars gets a opal or a gemstone from my my personal collection. Sorry, I lost my train of thought. Bum 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 bum. That actually went by so good, so good. I'm actually quite happy with that. I'm sorry if I stumble over some of my words. I'm not used to teaching in front of people. This is something I wanted to try, though. I'm just not a very good public speaker. Okay, our next stone that we are going to cover is called hematite. Hematite. I don't blame you. I know, but we're trying to give back to our furry community. We want to teach. Hematite. No, it's just, I don't know why, but I can just feel that there are people looking at me behind me. That's not a dig at you guys. It's just, this is weird for me. Okay. Hematite is a iron. Oxide. It has a Mo of 5 to 6.5. Thank you for the follows, Rax, Immortal, and Pa, by the way. I really appreciate y'all. Question, Teach. The RI is 1.74 to 1.5, or 1.75. To give you an idea, RI is really compared to a lot of things like diamonds. So for example, So for example, the refractive index of diamond is 2.4 to 2.5. well, 2.417 to 2.419. It's often rounded to just 2.42. But comparatively, it would be lower than diamonds. Opinion on sapphires. They are my fave gem. We love sapphires here. The only thing we hate is emeralds. We hate emeralds. Not because of their look, but because of the people who sell them. Awesome. We're doing great. Oh, Am I going too fast, by the way? Am I going too fast for anybody? I'm trying to be very slow. I lost my chalk. It's Jover. It's Jover. It's there. They do be trading for 11 bread. It's Jover. It's Jover. Okay, hematite is part of the trigonal crystal system. Okay, just for a visual example, here is our crystal systems. You can see our tetragonal and our trigonal here. Okay. Bum, 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 bum. Bum, bum, bum. It has what we call a metallic luster. What is luster, chat? This is a term from yesterday. As a metallic to splendent. Oh my god, we made it through one of the whole hour-long songs. Gummy, thank you for the follow. How light reflects off the stone. Correct. That is correct. So, some oxide minerals. Now, when we think of oxides, the big ones everybody thinks of are corundum, sapphires, and rubies. But the big one that not a lot of people think about is there's a lot of metal lusters. There's a lot of metallic. Thank you for the follow, Bolty. I appreciate you. There's a lot of metallic lusters and a lot of like things like that. There's a lot of. It's not just crystals like spinel, crystal beryl, and oh, thank you. By the way, I forgot to redeem that hydrate, so let me take my drink. Okay. Just be prepared, chat. In a second, we're gonna start asking questions. Hey, y'all. You two, in the class. Move to the center, up front more. I'm going to be calling on you guys in a second. Okay? Okay. Now, hematite is used in jewelry a lot. It's used in a lot of cheaper jewelry. But it's also historically ground into pigment. What color do you think hematite turns into? Don't mind. I will give you guys a visual example in just a second. Okay. Red? Oh my god. I love this person. You are correct. It turns into what we call red ochre. Here is what our hematite looks like. This is what hematite looks like. It is a iron oxide. Okay? Pass that to the class. And we grind it into red ochre. This will be on the test. This will be on the test. I'm joking. I don't know what will be on the test. Now, is this Mo high or low? Is a Mo of 5 to 6.5 low or high? Low? You are correct. It is relatively low. When you think about the aspect that a topaz is an 8 and 2.5 times harder, which is a 9, is a sapphire, a 5 to a 6.5 is quite low. This is on the level of some opals, so it's not very good for things like rings and things like that. It is good for like more pendants, okay? So, what do you guys think they use this mostly for in the gem world? It's mostly used for ornaments, as an ornamental or decorative piece. Okay, we're gonna move on to a couple other things. We're gonna go more broad on oxides in general. What are we thinking, class? What are we thinking on oxide so far? What's our favorite of the 4 oxides? Do we like chrysoberyl? Do we like spinel? What do you think?
Spinel.
I think spinel's really cool.
Spinel is very nice. We do love spinel. Where did the green one go? The green one left. He left us.
Yeah, we were motioning to him, but he's been gone a while.
Yeah, he died. He told me in chat. Spinels are nice. What do you guys think?
Skipping class.
No, I sent him to detention. I sent him to detention. Anyways. I sent him to detention. Okay. Good job, chat. Good job. Hematite because it can be found in banded iron formation. Good job. I love that. I love when you guys pull stuff out like that. Okay? We're going to erase this board. Am I going too fast, guys? How am I doing? By the way, Lord Salt's chat. What were you guys streaming? What were you guys streaming? What were you guys talking about? Good pace? Awesome. I love that we're at a good pace this time. Normal storage, display conditions. Okay. Okay. Sir, this is a classroom. Okay. So, here's something that I want you all to think about. Do you guys think that there is a care for these? We did character design talk, then played Make Good Choices and finished with Fire Emblem. Aw, that's cute. We are spending our free time learning. I'm spending my free time teaching. Okay, so not a lot of people understand this, but things like our spinels and our corundum. Quick, somebody tell me what it is. What am I looking for when I say corundum? I want to see the chat. If there are people behind me that know the answer of what I want, you can also say it.
Rubies and sapphires.
Good job. Good job, Eternal. Good job, Post. Okay, when we're talking about things like our spinels, our corundum, and especially our chrysoberyl. Yo, what's up? We are teaching. Welcome to class. We are learning about rocks. I'm Smokey. I'm a professional gem dealer. Okay, so what do you think we need to think about when we're talking about gem varieties of oxides for care? Well, we need to limit their light exposure. Why do you think we limit our light exposure? Why do you guys think we limit the light exposure of gem varieties of our spinels, sapphires, rubies, and chrysoberyl? Why do you think we limit light exposure? Via coating. Oh, 1 second. What do you think, Sam? Why do we limit our light exposure?
Is it because they can fade?
Sam is correct. A lot of people don't know this, but when you have gem varieties of these, and they are in the light, in normal UV light all the time, they can actually lose their quality. So one of the things we do is we limit light exposure. And that's kind of weird. When we talk about alexandrite, what is the thing that people love about alexandrites? It's that they change color in different light. So it's just one of those things. Not a lot of people think about this, but this is something to think about when you're buying a oxide. And mind you, this is prolonged light exposure. You know, this would be over years of being in the sun. But it is something to note. Okay? Chat, we are going to ask some questions. You guys are going to have some answers. This goes along with the people in the VODs. This goes with the people in the back. I want to hear some answers. Okay? We're going to cover some of the stuff we've talked about already. Okay? Are you ready? Good job. I'm excited. Ooh. So, first things first. What is an oxide? Is it sun exposure specifically or just light in general? It would mostly be sun exposure. When they talk about light exposure in gems, they talk about sun exposure. But light exposure in general as well. You know, it's just light. Because light bad, I guess. I don't know. So I should put sunblock on my rock. No, you should put your rock in a dark, dark spot. Sam!
So oxides are where one or more metals bond directly to oxygen.
Correct. We're going to write this very simply, but oxides are where one or more. We're going to use the word MET for metal here so we can save some time. Metals bond. What is the word? They bond directly to oxygen. Okay, that is number 1 on our oxides. Okay. What are our 3 premier gem quality oxides? Let me see if there's one in chat that gets it. It is our number 1 is our corundum. Number 2 is our chrysoberyl. What do you guys think number 3 is? It is our spinel. Our spinel. Good job, Post. Good job. Bum, bum, bum. Bum, 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 bum. Okay. What mineral is spinel historically mistaken for? Mistaken Rubies. Rubies is correct. We did get you. I noted that. Sam did put their hand up. Rubies. Okay. What are two famous rubies that are actually spinel? Okay, I'm going to take first one from Spade.
Black Prince?
That is correct. The Black Prince ruby. And then Sam?
Timur.
Good job. Eternal and Post. Good job on that. So it is. I lost my. It just Jover. Not Jover. I got my chalk back. Okay. It is the Black Prince Ruby. Or rubies. It could be more. I don't know. I didn't do that much research into it. And Timur. Who knows? I could be pronouncing that wrong too. Mistaken for ruby. These are spinel. Okay. We're going to recap. An oxide is one or more metal bonding directly with oxygen. There are three main types of oxides that are gem quality. We have our corundum, our chrysoberyl, and our spinel. Spinel is mistaken for rubies. Two famous rubies that are spinel are the Black Prince ruby and the Timur ruby. Okay? Chrysoberyls have three distinct gems or gem varieties. What are they, chat? We're going to take one from chat and then we'll see if our class has any for us. So what are our three distinct chrysoberyls? Regular. That is correct. Sam, do you want to come write the second one up on the board?
Oh. I was already with this.
Alexandrite is close. Well, Alexandrite is our number 3.
Let me get. I just gotta remember how to write it.
We're gonna have our class write our second one. Harder than it looks, right? Harder than it looks. Cymophane. That is correct. There are 3 types of our chrysoberyl. It is our regular, which is our yellows. Our cymophane. What does it mean when it has chatoyancy? What is chatoyancy, chat? Cat's eye. That's perfect. So we have a regular, a cat's eye, and alexandrite. What does alexandrite do that makes it special? It changes color. What colors does it turn? Turns green and red. Now we won't write it, but what is the saying? What is the saying when you talk about an alexandrite? Spades got it.
Shoot. Emeralds by day, ruby by night?
Correct. It is emeralds by day, rubies by night. Okay? Okay, what is one thing? Let me go up really quick. So spinels have something very interesting about them that makes them tougher than most. What is that? What is that? They have no cleavage. Boom! So what have we learned today so far? We have learned oxides are one or more metals bonded directly with oxygen. That the three main gem types are corundum, chrysoberyl, and spinel. That we know that spinel was often mistaken for rubies. That there are two super famous rubies that are spinel, the Black Prince ruby and the Timur ruby. We know that spinels are tough because they have no cleavage. And we know the three main types of gem chrysoberyl is regular, cymophane, and alexandrite. We know that cymophane has chatoyancy, which means that it is a cat's eye. And we know that the thing that makes alexandrite special is they change color. They turn green to red. It is known as emeralds by day, rubies by night. Are there any questions before we move to the next section of, basically Unit 4 of our teachings? Do all gemstones in the cubic crystal system have no cleavage? No. No cleavage is kind of special. It's kind of special. How am I doing so far, though, chat? We're doing good? We're doing good? I'm getting thumbs up in the class. I will say it's so awkward looking at you guys and then looking at chat and then looking at you guys. Okay. I'll start erasing the board. Also, I don't know if Rice is in here, but let's get a big thank you to Rice. Rice really pushed me to stream lately and has been helping me a lot with this stuff. Okay. Are there any more questions before we move on? This is the time to ask before the quiz. The quiz isn't just yet, though, by the way. Do you guys have any questions for our people in class?
It was on whenever you showed us the hematite.
Mm-hmm.
So it's all hematite. Is it
Yep.
the same type of hematite? Or
Yes. So hematite.
So why do they look so vastly different?
It's just formation. When they form, they're you got to think they're not forming in a concrete matter each time. They're forming in different places, different volcanic structure, different. A lot of people think that a lot of these gemstones just come out of the magma, but what actually happens is that a lot of these gemstones form from what we call fluids, right? When you superheat a gas, it actually turns into a fluid, right? And these fluids are then what forms our bases of our crystals, right? Like a lot of people think diamonds. We can use diamonds as a good example. When we think of diamonds, a lot of people are like, it's just carbon that's really condensed, but it's not. We're talking deep in the earth mantle. Carbon atoms are bonded together on a molecular level, you know, and they're bonded over millions and millions of years through these superheated fluids. Over time, they turn into diamonds and then are ejected out when volcanic material gets ejected out into the crust, and that's how you get diamonds, right? You got to think of the rest of these stones in a very similar manner. That a lot of them come from fluids that mix in with other stuff, and then that is how you get your gemstones. Okay? Did you have a question, Sam? Okay, I think we're good to move on to our next topic. I like sitting on my desk. It made me feel like a real teacher.
Glad it did.
I'm so cool. I'm so cool. I'm such a good teacher. I teach the furries. I teach the furries to be gemologists. Okay. Is everybody excited for the next part? Let's get excited. Let's get to the hands. Oh, I'm joking. Okay. Oof. Okay. We're going to talk about a little bit of some stuff like this. Can I change this? Okay. Okay, what is a primary deposit, chat? What is a primary deposit? What is a primary deposit, chat? Something that is directly deposited in. So a primary deposit is where a gem is found in its original host rock. We're going to use OG as an analog to save time. Okay? So, a primary deposit is where a gem is found in its original host rock. Okay? What is a secondary deposit, chat? We call these alluvial. What is a secondary alluvial deposit? I will spell alluvial on the board for you guys. It is ALLUVIAL. What is a secondary alluvial deposit, chat? Is where a gem is washed out of, what do you think it's washed out of, chat? Where a gem ends up due to erosion, but we're looking for it washes out of its original, we're using OG again, rock, and what happens to it? What happens to the rock after it's washed out? It doesn't just disappear. Spade? Okay, have a great time.
Good night.
Good night.
Class.
Of course. It washes out and is concentrated. in river gravels. Gravels. Okay, so primary deposit is where a gem is found in its OG host rock. A secondary alluvial deposit is where a gem is washed out of its original rock and concentrated in river gravels. Okay? We were just talking about this a second ago, but gems form from fluids. Fluids that escape from magma. We're going to pretend like that says escape from okay. Okay. So I think we're doing good. Are we good on this part? Can we move on a little bit? Okay. Ooh. Okay. Now, I'm going to go over a little bit of this, but we're not going to write it down. It might be a little too advanced, so we might move on to more advanced things later on in the future. Okay? But, corundum. We're talking about our sapphires here. Okay? Corundum. Let me erase this board real quick. Boom. Bum, 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 bum. Okay. How do you guys think corundum forms? So corundum crystallizes in via very hot fluids. Okay. So here, well, we might squash some stuff here. So corundum crystallizes in slow cooling igneous and metamorphic rock. The slower the rock cools, the larger the crystal can grow. Okay, so where's my chalk? Oh, there it is. Okay, slower rock cool. Slower rock cool equal big crystal. Trying to simplify it for y'all. Okay. But the slower the rock cools, the bigger the crystal. Corundum won't develop in just any rock. Okay. it has to be rich in what? What do we know that corundum is made of? It is a what oxide? So it needs to be rich in
Aluminum.
aluminum. Good job. So not just any rock, it has to have aluminum in it. Okay? Okay? And it has to be devoid no silicon or no silicon. No silicon. Okay? Now, the silicon-free part is like the most important part. Silicon and aluminum compete for the same bonding sites. So where silica is abundant, that's where quartz forms. Where aluminum is abundant, that's where corundum forms. Okay? What two gems are corundum? I know we keep repeating it, but we should know this by now. Sam.
Ruby and sapphire.
Rubies and sapphires. That is correct. So, one thing that rubies form in is marble. Okay? So, rubies form in marble. Sometimes. Ruby, marble. Okay. That's when like an impure limestone is subjected to regional and contact metamorphism in aluminum bearing minerals, recrystallizes as corundum. So this is something that happens. Thanks for letting me in stream. It was fun. Have a great night, Smokey, Teacher of the Year. Huzzah! Guys, if the Furry like Academy Awards doesn't give me Teacher of the Year, I'm gonna be pissed. I'm gonna be pissed. So some sapphires and rubies, some of the highest quality ones, are formed in marble. Okay? We're gonna move on. We're gonna try and go a little faster because this stuff is really complicated. We probably need to learn a bit more. Okay? Notebooks class. Notebooks. So spinels. What do we think spinels occur in? What mineral makes a spinel? It has to form in what? Something that is what rich? Magnesium rich limestone. Rich limestone. Okay. Spinel forms in magnesium rich limestone. Okay. And these have to be subjected to contact metamorphism. So really, really, really strong stuff. Rig rentals. Hi. I've once again been unable to lock in, so I'll have to rewatch this class as well. You're totally fine. That is a good segue. All these classes are uploaded as VODs on my YouTube. Please go watch them. I really am trying to educate the masses here. Okay? So, there is overlap here. The reason why there is overlap is spinels also form In what? What do you guys think that why there's some overlap in our like sapphires, rubies, and our spinels? Well, it's because they form in marble. Spinels also form in marble. From metamorphosed limestone. Okay? Okay. I think we move on from this because this gets quite complicated quite fast. Okay? But just know, I'm rooting for you. Okay. Crystal Barrel. So Crystal Barrel is different from our corundum and our spinel. Okay? It requires what? What did I say? What, it's a B word. What forms Crystal Barrel? It is what forms Crystal Barrel, chat? Beryllium. That is correct. And this is rare. Beryllium is a rare element in the Earth's crust. Beryllium is rare. Okay? So, as a beryllium mineral, Crystal Barrel only forms under these conditions. Where large amounts of beryllium are present, this limits its amount because of how rare it is. I'm unfortunately having to leave. I hope y'all have a good night and enjoy the stream. Thank you, Tired. I appreciate you. Okay? Crystal Barrel usually forms in pegmatites. Okay? It forms in, or I guess I always pronounce this wrong. It's pronounced pegmatites. But I say pegmatites because I'm an idiot. What is a pegmatite, chat? What is a pegmatite? Forms in pegmatite. What is that? What is that, chat? What do you guys think a pegmatite is? Pegmatite has very large crystals. So a pegmatite are thought to form from the last fluid fractures of a large crystallizing magma body. Okay? This residual fluid is highly enriched in volatiles and trace elements, and it's very low viscosity. Okay? Which allows components to migrate rapidly to join an existing crystal rather than coming together to form new crystals. Okay? So this allows what? This allows very few large crystals. So very few large crystals. I'm not gonna lie, this is the part of a vein of beryllium. No, we're talking about things that are rich in these sources. This is why these crystals happen. I will say this is the part where I was worried about the most, because this is highly complex, like chemistry science type stuff. So if I am going too fast, let me know. Okay? So pegmatites are essentially pegmatites. God, I hate that I say it wrong. Pegmatites are essentially the last gasp of a cooling magma body. Okay. So it's kind of like chemically exotic, water-rich, final liquid. Okay? And we're moving on. We're moving on. Okay. We have pretty much reached the end of the class I had today, which sucks. I was hoping it would go longer. So I do want to answer some questions that I kind of wrote down that I feel like people ask sometimes. So some people ask why formation matters in the gem trade. Okay, that's because formation environment directly determines the three commercially significant factors of a stone. A lot of people will tell you, or a lot of stones will be sold as a Myanmar sapphire, a Myanmar ruby, a Colombian emerald, right? Origin is super important when it comes to gemstones, okay? So when we talk about why formation matters, number one on this list is origin, okay? Where it comes from. Number two, why else do you guys think formation matters? What other thing could formation cause that would matter stone-wise? It can cause inclusions. Rarity, close. Inclusions. We're just going to call this stuff. You know, inclusions in the rock, that's just stuff. And post, you went ahead of me. You went ahead of me. Rarity is our number 3. Okay. So, what makes formation for these gemstones important? Firstly, it is its origin, where it's from. Okay. Then it's its inclusions, the stuff that's in it, and rarity. Okay. The more unusual the combination of geological conditions, the rarer the gem. That is why alexandrite is so rare, because it needs two incompatible elements to meet in the same rock very, very precisely. That's why alexandrite is so rare. Okay? Now that we have reached the end, it's time for what do you guys think it's time for? What do you guys think it's time for? What do you guys think it's time for? It is time for a pop quiz! Oh my god! It's time for a pop quiz! It's time for a pop quiz! I'm so stoked. Are you guys stoked? We're going to... Where is it? Cool. Can you feel the mood just change? It's pop quiz time, guys. It's pop quiz time. This is a staple, or going to be a staple of the Smoky Stream. I will quiz you on what you need to learn. I will quiz you on what we have taught. I am not ashamed to pull things out of previous streams, so please go watch the VODs, okay? So, first question, okay? What is the defining chemistry of an oxide? What is an oxide? What is an oxide? What is What is oxide? It is a compound where one or two metals directly bond with oxygen. Good job, random. Metal. We're going to write this metal plus oxygen. Perfect. So far, so good. Now, here is one that I'm not going to write down, but we're going to get an answer. Which of the following is not a gem quality oxide? Is it emerald? Is it sapphire? Is it alexandrite? Or is it hematite? Which one is not an oxide? Sam?
Hematite.
Nope, hematite is a oxide. It is emerald. Emerald is a what? Emerald is a silicate. Emerald is silicate. The one I hate. It's the worst. Okay. Number 3. What is the chemical formula of corundum? We're talking broad. We're not talking about like everything. We're talking broad. Sam.
Aluminum 2, oxygen 3.
Perfect. Post and Sam got that one so fast. Al2O3. Dang, we're blazing through this. Okay. By gemological definition, what makes corundum what makes corundum as a ruby different from a sapphire? What makes a ruby different than a sapphire? Ruby has chromium. Okay, think more broad. Think more broad. What is the difference? Chromium is correct, but I want to see. Let's dumb it down a little. Chromium. Its color. Okay, what color is a ruby? Sam.
Red.
It's red. Good job. Good job, Post. Good job. Good job, Eternal, as well. You guys are doing good. Okay? Number 5. By the way, this is a 12-question quiz. Okay? Now, we are exiting. We are exiting the beginner part of the quiz. Okay? Okay, what famous gemstones have been mistaken for rubies? What famous gemstones that we covered today have been mistaken for rubies? The Black Prince's rubies and the Timur rubies. Good job. Sam also gets credit for that. He raised his hand. What are these, chat? Secondary question, what are these? What are they actually? They're not rubies. What are they? Sam? Oh, Eternal got it. Spinel. You know, you don't have to raise your hand. You can. I feel bad. You can actually
I know,
just.
but I want chat to also say stuff. I don't want to keep saying stuff.
My hand died. So, give me 1 second. You guys are halfway through the quiz. You guys are doing good though. I'm actually quite proud. I am quite proud. Everyone's making me quite proud. Can I have my controller back? Well, this is one of those days. I have no arm now. Okay. I don't know what happened, but we're going to pretend like something happened. We're going to go on to our next question. Oh, I got my hand back. Look, I'm back. Okay. Okay, these are... I lost my chalk. There it is. Ha ha, ha 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 ha. Spinel. Okay. Number 6, chat. Is everybody ready for number 6? Okay. Why is spinel considered exceptionally tough? What does it not have? Sam.
Cleavage.
Cleavage. Good job, Post. Good job. Okay, number 7. This is on Crystal Barrel. So if you have notes specifically on Crystal Barrel, go there. What is it called when I say Crystal Barrel has a cat's eye? What do we call it? What do we call it? Starts with a C. Cymophane is what it's called. No. What does it have? Chatoyancy. And what is chatoyancy? This is one I expect Post to get. What is chatoyancy? What causes chatoyancy? Fiber is close, Post. We're looking for another word. Starts with an N. Parallel inclusions. Parallel needle inclusions. We're going to pretend that says inclusions. Number 8. Number 8. We're getting into how they form now, okay? So what element cannot exist if we want spinel, or if we want corundum to form? What mineral, what element cannot be there? It has to be devoid of silicon. Good job. 9. In which rock do spinels and rubies form? That they get confused. Starts with an M. Sam gets it. Marble. We call it dolomite marble. Number 10. Okay. Why is Alexandrite so extraordinarily rare? What two things does it require to form that do not like each other? You guys got this, chat. Huh?
Beryllium.
Okay, beryllium is one of them. What is the other one? What does beryllium not like being near? It has two incompatible elements. What are they? Chromium. Good job, chat. Good job. I'm actually quite impressed. We're going to go for 11 now. So far, we're 100 for 100. See, this is where I'm going to get you because I think the last two questions are from the previous stream. I'm evil. I'm evil. Okay. What mineral or what gemstone belongs in the cubic crystal system? I will accept 3 different answers. What gemstone? Diamond. Diamond is 1. Spinel is 1. I will take 1 more. Topaz? Close, no. We're looking for one with a G. One with a G. Hematite, no. This is from previous stream. We're talking about garnet. But you only needed 1 to pass, so we are happy. Okay, now here's our last one. Last question. Are you guys excited? Are you guys excited? Name 1 organic gemstone. I will take 5 answers, but you only need 1. Amber. Amber is 1. I will give extra credit for if you can name the younger version of amber. Coral is 1. Copal. Copal is correct. That is the younger version. Pearls. That is correct. I will accept 2 more. One of them you cannot buy. You should not buy. Jet is one of them. Ivory is the last one. And for what extra credit, what is the only type of ivory that I think you can buy? Mammoth is correct. Good job, chat. Good job. Big round of applause to everybody who showed up. Okay. You guys did really well. Really well. How did I... Okay. I'm going to change the music really quick. go to something more like this. Okay. Killing it, chat and class and teacher. Aw, thank you. Okay. So this is the part of stream where I ask you guys what I can do to be better. Did the visual aids help this time? Did the visual aids help? Sam says yes. Sam says the visual aids did help. They made the class more engaging. The crystal system helps a lot. Awesome. Okay. So far we're doing good. Good. I didn't get to listen to a lot of this lesson, but when you asked things covered in previous ones, I remembered easily. I'd say you're doing great. Okay. What would you guys like to cover in the next class? What do you guys want to cover? Something like the Garnet supergroup? What would you guys want to cover? That would be a longer stream, I will warn you. Fossils. Well, we'll do fossils. We will do fossils. We will do fossils. Okay. Is there anything that you guys think I could do better? Anything at all? Was I too fast this time? I know that was a thing for a couple of streams, or the two previous ones, is that I was moving too fast. Do you guys think I moved at a pretty good pace? Not really. There was enough time to take notes comfortably. Okay. Should I preface in like the beginnings of the class that we should take notes? Oh, what's everybody thinking of the pop quizzes? Pretty good pace. I was able to keep up with my notes without having to rush. Okay. What do we think about the pop quizzes? Do we like those at the end? Are those stressful? Should we not have them? What do we think of those? Love the quizzes? Okay. I like the quizzes. Okay. Do we like the idea of this is a soft idea, so give in mind that like the first month is going to be pretty difficult. But do we like the soft idea of the stars, giving the stars and then giving away a piece of like a personal gemstone I've cut to a member of chat? I thought it would keep people engaged. I came back and basically missed everything. Don't worry, this one will be uploaded as a VOD right after. But what do you guys think of the, like, what do you guys think of the idea that we work on, like, a star system? Because I want to keep you guys engaged, but I want there to be a reason. Like, if there's no reward, then there's no reason to take notes, you know? That's one of the things I was thinking of.
Could do a Google form.
So the whole
or
goal,
a test.
the goal for like the end of the month was to do like a proctored exam. like a Google form that people submit, and whoever got the most answers correct, and this is like obviously when notes allowed. Obviously, I can't look over your shoulder, but the person who got the most answers correct gets something from my collection. It's great. It's a great way to motivate us, but it's fine. Learning is enough. Make sure that you don't feel bad about rewarding a stone from your collection. Well, I cut them anyways. No, I would pay for the shipping. It would be like a once a month, like, exciting, like, thing that we do. Rocket! We were wrapping up! Okay, well. Hi, I'm Smokey. I talk about rocks. We just finished our class on Oxides. Thank you for the follow, Husky. I guess we could do another class. I'm celebrating my 1-year mod anniversary. That's hi, Snowy. Hi. Boyd, thank you for the follow. Apricot, thank you for the follow. I appreciate it. Okay, so we just covered our class on oxide minerals and oxide mineral formation. We are totally able to do another class if you guys want, but we'll let Rocket pick what it is. Deoxides. Thank you guys all for the follow. Thank you, Wilson. Thank you, Kai. Thank you, I think it's Lucin? Diamond Market. Oh my god. Okay, so diamonds. Do we know how diamonds form, chat? How do diamonds form? If anybody says compressed carbon, banned. I'm joking. Teach. Do we get a rock and stone? We do. Actually, we have a system for this. We do a quiz at the end of the lessons where people can get stars. At the end of the month, we do a big quiz where people can use notes. And if they get 100%, or if whoever gets the most answers correct, gets a stone from my collection. Pressure and temperature. Close. Squeezed carbon. No. Okay. So, diamonds are formed from hot hydrothermal fluids deep in the mantle. I need to change this. I need to change us back to learning music. We're learning music now. We're learning music. Okay. 1 second, guys. Okay. Ooh, this is a lot of people. I am nervous. But you know what? I'm prepared. I'm so cool. I'm so ready for this. I'm so ready. I'm ready. I'm ready. Okay. Fluids like hydrocarbons. Okay. When diamonds form in the crust, a lot of people think that it's just you take a rock and you compress it down. But what it is that a lot of these gases actually are more considered fluids. Imagine that you heat up something up so much that it turns into a fluid. Void, yes, this is Plants vs. Zombies music. But imagine you heat something up so much that it turns into a fluid. Over time, this, did you shout out Rocket yet? No, could you do that for me? So as you heat these up so much, over millions and millions of years, the carbon atoms start to form and piece together. They bond over time. Okay, here's a big thing. Here's one of the things we will... Okay, we're going to do diamond formation, and then we will work on diamond market, okay? Okay. Go. What is the main element in diamonds? What is it made of? The main element, not fluids, but the main element. It's carbon, right? We all know that. Right? That's so important. Carbon is so incredibly important. Carbon is widely... Thank you guys for the follow. Thank you, Mistigan. Thank you, Hamburrito. Thank you. So, carbon is widely dissolved. Okay, dissolved to parts per million levels in Earth's silicate minerals. Earth's silicate minerals. Okay. But whenever carbon occurs as free species, diamonds have the potential to form. Okay. Now, so for a good thing to actually talk about is carbon doesn't also just form the hardest mineral on Earth. You know, we all know diamonds are 10 on the Mo, right? But carbon also forms one of the softest minerals on Earth, called graphite, which is a 1. It's just different formation, okay? So, we'll talk about this. Diamonds can be as old... How old do you guys think the oldest diamonds are? $4 billion years, you're about 1 billion off. Some of the oldest diamonds are about 3 billion years. Some of the youngest diamonds are about 90 million. I almost said billion, and I was about to be like, Smokey, you're an idiot. 90 million, okay? So some of the oldest are 3 billion years old. Some of the youngest are 90 million years old, okay? And this is at a depth where they form at 90 to 400 miles beneath the surface, under surface. Okay? So, what do we know so far? What do we know about our diamonds so far? We don't know that diamonds are formed from carbon, that carbon dissolves or is dissolved amongst almost all Earth's silicate minerals. We know that carbon can form diamonds, which are a 10 on the Mohs scale, and graphite, which are a 1 on the Mohs scale. We're talking natural diamonds, but we will get to lab diamonds. Trust the process. I am a good teacher. I'm joking. Some of the oldest diamonds are 3 billion years old, and some of the newest diamonds are 90 million years old. And these form at a depth of 90 to 400 miles under the surface, okay? Now, this is extreme temperature, okay? We're talking close to more than like 2100 degrees Fahrenheit, okay? And this would be at a pressure. Oh, can I have this? Thank you. This would be at a pressure of, get this, 45,000 times sea level. Okay. Okay. So we know that diamonds can form at around 2100 degrees at 45,000 times sea level. I don't think I could survive. I think I could. I think my bombastic side eye would save me. Now this causes carbon to fuse or to form close, tight, incredibly tight bonds. Carbon at this temperature and pressure forms tight bonds. Forms tight bonds. I don't know why I spelled tight with a Y, but we're going to ignore it. Bonds, okay? And this is what produces the hardest gemstone on Earth. Bombastic side-eye. Bombastic. Okay? Now, we're going to use a visual reference, but our diamonds are part of our cubic crystal system. Okay? We have 7 crystal systems: the cubic, the tetragonal, the monoclinic, the orthorhombic, the triclinic, the hexagonal, and the trigonal. Okay? So it is a part of the cubic crystal system. We also call it the isometric, but for now we'll call it the cubic because it is a cube. You know, I just came back to say this rocks. Oh, thank you. Okay. Do any of you guys have any questions? I will pause for just a second so that we can have some questions. Are there any questions here? There will be a 10-question quiz at the end, by the way, Rocket, and I expect you to win. Can you put the camera lower? I can definitely try. I think you can see the board just fine, but there you go. Side question. Could I DM you later about streaming setup? Streaming setup. Are you trying to stream? I'm not going to lie. I just started. I'm not the person to ask. We just got done with a quiz, and there's going to be another one. There is. Pop quiz. Perfect. Do diamonds have cleavage? I don't know. We'll look through in my notes. I did not expect this to be a class until much later, so... Okay. Now, air writing notes. Yes, I actually have a bunch of Google Docs where I have all these like classes set up. So, okay, I'm just kind of reading my notes. Just give me one sec. More so about your format. It's something similar to what I have in mind. Mostly, I just come to this world, I do a shit ton of research, and then I just talk. So diamonds, they crystallize in stable lithospheric mantle roots beneath ancient continental cratons. Okay? So, We'll write this down. Probably erase this board. Just so that it's easy. So they form in stable, lithospheric, mantle roots. Beneath ancient continental, we're going to use con as an analog so we can save some time. Under ancient continental cratons. Cratons. Okay. These cratons act like think like diamond factories, right? Over like metric amounts of time, right? A craton always contains the oldest rocks within the host continent, okay? And typically these ages range from 2.5 billion years or older, okay? This geological era would be known as what? It would be known as the Archean. The Archean. I spelt it with an O, but it is an A. The Archean era. Okay? I'm going to ask now, so speak up or forever hold your peace. Do you want a visual example? Because I will get you a visual example right now. Thank you for the follow, Jack. I appreciate you. Yes, the visuals definitely help. Okay. I'm getting you a visual example right now. Right meow, actually. Right meow. Okay. Okay. So I have a simplistic one, and then we have a detailed one. Okay, we'll go simplistic first. Kind of get everybody in the know, and then we'll go from there. Okay. So this is what diamond formation looks like. Okay. We have our crust. We have our continental plate. We have a kimberlite pipe. This is how the diamonds get from the mantle to the surface. Okay? Diamond formation happens here in the mantle. Okay? Pass that to our class. Okay. Now, this is a more detailed reference. If you need to take a screenshot, take a screenshot. Okay? But what we call, this is called a subduction zone. Okay? Here. We have our low mantle, our super deep diamonds, our lithospheric diamonds, the transition zone, and our asthenosphere. Now, these are the kimberlite pipes where we get our ejection out for our diamonds. This is like something out of a textbook because I pulled it out of a textbook. And then you can see where the craton is, okay? They wanted to talk about diamonds. They wanted to talk about diamonds. I'm talking about diamonds. Okay. So diamonds is a somatic, metasomatic mineral. Okay. That is spelled Matic. It's a metasomatic mineral. Okay? That forms during the migration. It forms during, we're going to use the word MIG for migration, okay? MIG. So if you see MIG up here, that means migration, okay? During migration of carbon-bearing fluids. Okay? One second. Sorry, reading my notes and doing this with time is hard. Okay. So, we know that diamonds come from the stable lithospheric mantle, okay? Where under ancient continental cratons, okay? We know that this is during the Archean era, okay? Now, we know that it is a metasomatic mineral that forms during the migration of carbon-bearing fluids, okay? And this just means that it forms from fluids and melts that move through the mantle. Does that make sense? Does that make a little better sense? I gave you the scientific, now we're going... Okay? Diamonds can form in both peridotite and eclogite in the chromatic lithospheric mantle, as well as their higher pressure equivalents in much deeper transition zones and lower mantles. Okay? That's what we learned over there, that there are super deep diamonds and then there are the regulars. Okay? Now, what is the two primary rock types are peridotite. Okay? And this means that it's just the predominant rock. The predominant, we're going to say for predominant to save time, rock in the upper mantle. In upper mantle. Okay? So we know that diamonds can form in peridotite, which is the predominant rock in the upper mantle. Okay? Good. Now, eclogite. Is ancient seafloor rock. Seafloor rock. Bum, bum, bum. Okay? Okay? Does anybody have any questions for me? Any questions? Now, we already kind of discussed it, but the oldest diamonds, so the absolute oldest of oldest diamonds are about 3.5 billion years old. Okay? Now, in perspective, the Earth is 4.54 billion years old. Okay? So, about a billion years after Earth forms, we start the formation of diamonds. Okay? Diamond growth may occur somewhat quickly. It's compared to its age, right? Building up crystal layer by crystal layer over thousands or millions of years. So it can, what's the second word? The second word is eclogite. Eclogite. Sorry, I should have spelled that. That's my bad. Okay. Now, we already know how it makes it to the surface. It travels through kimberlite magma. Okay? So, kimberlite magma pipes. Diamonds lay hidden deep within the Earth for millions of years before being transported to Earth's surface by violent volcanic eruption. Okay? The magma rips up pieces of diamond hosting mantle, rocks hundreds of kilometers or miles, depending on how you want to say it, below the surface. During this journey, mantle rocks break apart and release the diamonds into the magma, forming so-called xenocrysts. I will write that word for you for your notes. Xenocrysts. Okay? Which just means crystals foreign to magma. Okay? Kimberlite magma ascends through the lithosphere rapidly, causing both temperature and pressure to decrease rapidly, which potentially destabilize any diamonds carried within. The speed is critical. That is that's really important. Okay? If the magma rises too slowly, diamonds revert to graphite. So kimberlite magmatism enables diamonds to be transported rapidly from depths to the surface. Okay? Are there any questions there? Any questions? I probably will cover this class again, but I want to make sure that that we give Rocket something for being so nice. Okay? Now this is what we call primary deposit diamonds, right? Do we remember what our primary deposits are? What was the definition of xenocrysts again? Xenocrysts just means crystals foreign to magma. Now, primary deposits. That just means that the gem forms or is found in its original host rock, right? Now, we're going to talk about alluvial diamonds. What is our secondary alluvial deposits, chat? We just talked about this. That means that it is a gem that has been washed out of its original host rock and now lies within river gravel. Okay? So as erosion frees up some of the rough diamonds from the kimberlite, they end up in riverbeds and silt. These can now then freeze into glaciers, and the water can move. That means that diamonds that come out of one area can go thousands of miles from their original location. Even into the 1800s, the world's diamonds were found and collected in the soil and gravel of riverbeds. Okay? So a lot of the diamonds that they did find were secondary deposit diamonds. They didn't do as much heavy mining as we do now. Okay? Diamonds, extreme hardness of Mohs 10 and chemical stability meaning it survives weathering and river transport that destroys every other mineral around it, right? So it concentrates naturally in alluvial gravels. That just means that because of diamond's extreme toughness, that all the other minerals around it tend to break free of it. So that there's nothing around it. Usually they're found alone. Okay? Okay. I don't really want to go over that. So, we're going to go over our key takeaways. Whew. Unless, okay. Really quickly, do you guys want to go over diamond type or do you care? Do you care? Should we go over diamond type? We could. Yes, okay, yes, we do want to go over diamond type. Gosh, fine. Fine. Jesus. Okay. So, diamonds have 4 types. Okay? We have what's called IA. Okay? And this just means that it is, okay. For example, this just means it has an impurity. It has nitrogen in clusters. Okay, let's get some involvement in here. What is the percentage of diamonds that you think fall within the IA category? What do you think? Is it a lot? Is it a little? 8%? Well, you're a little off. It's a little closer to 95% of all natural diamonds are IAs. We're going to use nat here to save on space. Okay? So these are most common. They come out like a slightly yellowish tint, or clear. Okay? Then we have our IB. IB, which means that these have isolated nitrogen atoms. How many do you guys think that this makes up? How much percentage of diamonds? If this is 95%, how much does IB take up? Six, 60%, 1%? Close. We're looking at 0.1%. 0.1% of natural. Okay? Now these have what we call intense. We're going to use INT for intense. Intense yellow. Okay? We call these canary diamonds. Canary. C-A-N-A-R-Y. Demons. Demons. I'm gonna get on a double diamonds. Okay. Our next type is called IA. And this just means no nitrogen. No nitrogen. No nitrogen. How much do you guys think this makes up of diamonds? If this is 95%, how much is this? I'm sleep writing. Sorry, you're fine. How much is this? %? That's close. 1 to 2%. 1 to 2% of nat, which we're using nat as of natural. Okay? 1% of nat. Okay? These are usually colorless, but can sometimes be the finest whites, which is colorless, or sometimes soft pinks, some pinks. This is where you get your pinks. Colorless, no color, or pink. Okay? Now, we have IIB. Now, this means the same thing as IIA, except this means boron. It has some boron in it. Okay? And these are extremely rare. So incredibly rare that, 0.1, 0.01 doesn't even count. Extremely rare. Okay? Now, why do you guys think these are rare? It's because of the boron, right? This is where we get blue diamonds. Okay? This is where we get blue diamonds. Okay? Name a famous blue diamond, guys. Name a famous blue diamond. It's in the Smithsonian. Killed a queen or two. We call that the Hope Diamond. As a great example of a boron diamond. Okay? How are you guys feeling on types? We'll refresh, but here we go. IA diamonds. This means that they have nitrogen atom clusters. This is 95% of naturals, and they have a slight yellow to a colorless. Okay? We have IB, which means isolated nitrogen atoms. Okay? This is 0.1% of natural diamonds. We call these canary diamonds, and they are an intense yellow. We have IIA, which is no nitrogen, 1 to 2% of natural diamonds, no color, or pink. Then we have IIB, which is boron. No nitrogen, but it has some boron. Okay? These are extremely rare, and they make blue diamonds or hope diamonds. Okay? There's also something called a red diamond. What makes a red diamond, chat? What makes a red diamond? What thing do you think makes a red diamond? Chromium? That's a good guess. You know what it is? Nothing. Nothing. None. What happens is for red diamonds to form, they get so incredibly hot that it twists their chemical structure. It twists them. And they turn red. Do we know why? Not really. But that's how you get red diamonds. But they get hot and it superheats their already linked bonded structure and it twists. Okay? Okay. Can I erase this? We are going to cover our key points and topics. Are we good? Yeah, it's mostly color center. But red diamonds are so incredibly rare that it doesn't even matter. The likelihood that you will see a color diamond or I will see a red diamond in my lifetime, small. The last one I saw sold was like a 1 carat one, and it sold for $5 million. So they are that rare. Blue diamonds are like our second rarest. Okay. We're going to go over our key points, key topics. Oh, there's so much going on. 5 million for 0.2 grams is crazy. If you're rich, you gotta have it. You gotta have it. The rich get richer. Okay, diamonds are the only gemstone that form in the mantle and not the crust. Okay, diamonds form mantle. Okay, that's number 1. Number 2, formation requires extremely specific conditions. It is extremely specific. Extremely specific. They need an aluminum-free, carbon-rich environment with a 45,000 times pressure of sea level. They need to be around 950 to 1400 degrees Celsius. And they need to be beneath ancient cratons. Okay? Third thing, we know diamonds are old. The oldest diamonds are 3.5 billion years. That's billion with a B. They are ancient. But they were delivered to the surface in much younger kimberlite eruptions. Kimberlite is spelled Kimberlite. Okay? Kimberlite eruptions. Okay? The speed of this eruption is critical. If it's too slow, it turns into graphene, or graphite, sorry. Too slow, bad. Okay? Too slow, graphite. Too fast, or just fast enough, diamonds. Okay? What makes a kimberlite eruption from the mantle? Kimberlite, they're basically where you have a magma pipe, they call them kimberlite pipes, where magma flows to the surface. It's where there's just enough pressure that it flows towards the surface. Okay? Now, diamond types or classifications. We have IA, IB, 5, IA, IB, IIA, IIB. Okay? And these reflect the impurities. Okay? That encode formation history. These can help identify, for example, these impurities can help identify if a natural diamond is natural and a lab-grown diamond is lab. Okay? Okay, do you guys know what time it is? You guys know what time it is? Time is it?
Pop quiz.
Oh, yes. We love this time. It is pop quiz time. Pop quiz, pop quiz. Okay. Bum, bum, bum. Bum, 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 bum. Okay. Now, this is how it goes. Even if you don't know the answer, write it down. When you guys do this, we get stars, or you get stars, and you have a chance to get a piece of my collection at the end of the month if you work hard enough. Okay, what element are diamonds made of? What elements are diamonds made of?
Carbon.
Carbon is correct. Good job. Number 2. At what approximate depth do most gem diamonds form? Sam?
90 to 400
Oop.
miles beneath the surface.
Good job, chat. Good job. Everybody in chat and Sam got it right. 90 to 400 miles. Okay. Number 3. What type of volcanic structure carries diamonds from the mantle to the surface? What is it called? What is that called, chat? Kimberlite pipes. That is correct. Kimberlite pipes. Impressive. We're actually doing quite well. Number 4. Why does carbon form diamonds instead of graphite under mantle conditions? This would be two forces. Two forces. These are the two forces we've been talking about. The speed, no. We're talking about how they form in the mantle. We talked about the extreme heat and pressure.
100 degrees.
Yes. We'll take heat and pressure. Sam also got that. So heat
5,000 times.
45,000 times pressure. So it's heat and pressure. Good job, guys. Okay. Why? This might be a little complicated, but why do diamonds form preferentially beneath continental cations? Is it because A, it is very the mantle is very runny and hot and unstable, or is it because B, they're thick, cold, and stable? Which one is it? Sam is raising his hand.
B.
B. It is B. The thick. Thick.
Lithospheric mantle roots.
Indeed. Cold and stable. Spheric roots. Okay. How old are the oldest known natural diamonds? Number 5. So we might write number 5 over here. Pum, 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 pum. 3.5 billion years. Good job. 3.5 billion years. Good job. How do alluvian diamonds deposit? They're washed away. Correct. 6. They are washed away from their original host rock. 6. They are washed away. They wash away. We're going to pretend that says away. Oh, I see. I misnumbered these. I was so confused. I was like, what? Why am I missing one? Why am I missing one? Okay. 5, 6, and 7. That's my bad, guys. Sorry. Okay, we're on question number 8. Question number 8. Is everybody ready? I hope so. What is the most abundant type of diamond found in nature? What is the most abundant type of diamond found in nature?
IA.
IA is correct. IA. Number 9. Okay. Now we're going to ask some questions from a little earlier. Okay. What makes a blue diamond blue? What makes a blue diamond blue? What makes a blue diamond blue? It is boron. Boron. Last and final question. Are you guys ready? You guys ready? Which type of diamond makes 0.1% of natural diamonds, and what is its impurity?
IB.
IB, and what is its impurity? Isolated. Good job, chat. Good job. Isolated nitrogen. Okay. Did you guys have fun? Did you guys have fun? Was I informative enough? Our next class tomorrow. Next class will be on fossils. My notes were all over the place. Okay, this is for the people who don't know, this is the part of the lecture where I ask what I can do better. So if you have any critique, let me know. I would love to hear it. Yeah, I will say putting that together on the fly was a little wild and chaotic, for sure. We will probably visit this in a way more structured manner, but it was fun nonetheless. I'll rewatch this whole thing and be up to date on it for next class tomorrow. Yes, I stream it 5 p.m. Or no, 6 p.m. MDT, which would be 5 p.m. PST, and 8 p.m. EST. I upload all these VODs on my YouTube, and then we do so you can watch them for sure. Later on, I'll be making Google like tests that will go in the descriptions for each of those for people to have fun with while they're watching. Blah, blah, blah. Okay. Did you guys have fun? Can't buy the hydrate again? I will hydrate because I'm fucking thirsty. Push-ups? Oh, I hate you. I hate you. I don't like the push-up one. Post. I'm taking your point privileges. I'm taking your point privileges. Okay. Oh, we also play like horror games. We do a thing where we do recess. We take a break and we play horror games. But after this, I'm gonna be raiding out. You guys can go hang out with somebody else. I can't see where my chat is. Hello. Oh, that sucks. Bum 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 bum. I do need to go eat. Is the tracking good for that? I sure fucking hope so, because I'm not doing it again. Okay. On that note, please, if you have notes, remember that you're loved, that we appreciate you. It means a lot to me to have my good friend Rocket around, and my great friend Snowy, and my good person Romu. Fuck you. Never mind. I hate you now. 1, 2, 3, 4, 5. Okay, but it does mean a lot to me to have my good friends around me. They have been asking me to stream, and I've been trying to figure out how to do it. I like teaching. This is just what I like to do. Next class, tomorrow, fossils. Be there or be square. Okay, I'm rating. I'm done. I'm rating. Our raid message is, you look like a Cation. Citron. Or Creighton. Creighton? Is it Creighton? Is that how you spell it? I don't know. Somebody put it in there. Oh yeah, be there or be part of the cubic crystal system. That's gonna be our raid message. Be there or be part of the cubic. You're part of the cubic crystal system. That is it. There we go. That's the one. Who am I following? That is live. Da, 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 da. I think I'm gonna send you over to Dervish. That guy's so cool. Okay, raid message. You are part of the cubic crystal system. There you go. Okay. Thank you again. Really appreciate all y'all. You guys are amazing. Please let me know what I can do to be better. It means a lot. You guys are awesome. Okay. Have fun. Tell Dervish I said hi and that we talked about rocks. You guys are amazing. I'm gonna go eat some food. Yummy food. Yummy. Bye. Bye, everybody. Bye. Okay. Have fun with Dervish. He's playing Fallout New Vegas. It's one of my favorite games, I think. Bye.